The ICEVI, the Nippon Foundation Mathematics Package for Teachers video series, Abacus as a Mathematical Tool. Title of the video: Square Root of a 7-digit number involving many zeros. Let us take the number 6,057,000. We mentioned that this abacus with 15 columns is not adequate to place the digits and simultaneously do the decimal part of the square root. For doing that, we may have to use another abacus. Now, let us prove that this number is not a perfect square and it will leave a remainder at the end. It will also give practice to the child on how to deal with the numbers having larger number of digits. Now let us set this number without leaving the 3 columns on the right side of the abacus, which are earmarked for the decimal part of the square root. Let us set 7 in the extreme right of the abacus and 5 to the left of it. 0, 0, 0, 0. After 4 zeros, you set the number 6. Now, for the purpose of calculation of the square root, we have to group the number as 6, 0, 0, 0, 0, and 57. The first group contains a single digit number 6. Now consider the perfect square in 6 and you get 4. Now the square root of 4 is 2. As 2 is smaller than 6, you skip a column to the immediate left of 6 and set the number 2. Now 2 multiplied by 2 is 4. That should be subtracted from the 6 and you get 2 as the remainder. Now we have to go for the next group and therefore you have to take 200. In the next stage, double the number 2 and set 4 in the extreme left of the abacus. Now consider 20 of the number 200 and ask how many 4s in 20. You get the answer as 5. Reduce 1 and consider 4 as the assumed quotient. Set 4 to the right of the already set square root 2, which is making it 24, and also set 4 to the right of 4, which is set in the extreme left of the abacus. Now 4 should be multiplied with 44, which is 176. That should be subtracted from 200 and you get 24 as the remainder. Now we have to deal with the next set of number and therefore we have to consider 2400. Now double the square root 24, which will become 48. Therefore the number at the left extreme of the abacus will become 48. Now you can go for direct division process too. Now ask how many 48s in 240. You can also round it off to 50 and 250 and approximately get 5. And reduce 1 from here and set 4 as the next digit of the square root, making the 3 digits of the square root as 244. Add this 4 to the number 48 in the left extreme, making it 484. Multiply 4 with 484 and the value is 1936. You can use another abacus also to do this calculation without calculation. And this 1936 should be subtracted from 2400 and the remaining value you get is 464. Now you have to go to the last group, that is 57, and therefore you have to consider 46,457. Now you have 244 in the square root section. This should be doubled. That means in the left side of the abacus you have to set 488. Now take the first digit of 4 of the divisor and first two digits of the dividend, 46, and you get 11, and therefore take 9, which is the highest single digit number that can be treated as the fourth digit of the square root, making it as 2449. Add this 9 to the right side of the number 488, making it as 4889. When you multiply 9 with the 4889, which you can do it separately using another abacus, the value becomes 44,001. That should be subtracted from 46,457, which gives us the remainder 2,456. This indicates that the number 6,057,000 is not a perfect square. Now, the square root that you get so far is 2,449, and you also have a remainder 2,456. From here on, when you want to get a decimal part of the square root, you consider the divisor at the left side, which is double the value of the square root 2449, and start adding 0 to the remainder at every stage, and use the normal division process to get the decimal digits. When you go for the decimal digits, you can decide whether you should go for 1 digit or 2 digit or 3 digits. When you go for 3 digit correction of the decimal point using the normal division, by treating the remainder as the dividend and the double of the square root as the divisor, you will get 0.501, which you can do separately using another abacus. Therefore, the square root of 6,057,000 is 2,449.501, subject to correction of 3 digits in the decimal part of the square root. The purpose of finding out the square root of large numbers having 7 digits, 6 digits, etc. is to give practice to the child that there are a number of calculations within calculations. Here we have skipped the calculations that come within calculation. For example, multiplication of 9 with 4889, we have just used the final value. You can use another abacus also to do the calculation. So the purpose here is not to do the calculation at every stage. The purpose here is to explain the procedure so that the child is fully aware of finding the procedures used for square root.